In this video, we are going to try and use Raoult's law to solve this question or problem. A solvent Y of molecular mass 62 has a vapor pressure of 1.0 times 10 to the power 4 Newton per meter squared at 298 Kelvin. Calculate the vapor pressure of a solution formed when 23.3 grams of a non-volatile solute of molecular mass 270 was added to 10 grams of Y at 298 Kelvin. As you can see, we are having the same temperature. So all we need is to know what Raoult's law states in terms of relative lowering of vapor pressure. So Raoult's law states that the relative lowering of the vapor pressure of a solvent in which is equal to the mole fraction of the non-volatile solute dissolved in that solvent at a given temperature. As we have seen, the temperature has been given, although we shall not use it. So we just need to know what it means by relative lowering. Remember, the vapor pressure of a solution is lower than that of a solvent. So we know that let P be our vapor pressure of the solvent minus the vapor pressure of the solution. So this relative lowering, this is the lowering. Vapor pressure of the solvent minus vapor pressure of the solution, that is vapor pressure lowering, because we know the solution vapor pressure is lower than that of the solvent. So if we divide this by the vapor pressure of the solvent, then we are having our vapor pressure lowering. So this is known as vapor pressure lowering, P solve minus P solution over P solve. So this is equal to the mole fraction of the non-volatile solute. So let X be the mole fraction of the non-volatile solute, which is also equal to the number of moles of X, which is our solute, divided by the number of moles of our solute plus the number of moles of our solvent. So we are going to use these two equations or this one equation to try and solve for what have they asked for? Vapor pressure of the solution. So we want to find the vapor pressure of our solution. So we have to ensure that we have all other terms. Vapor pressure of this solvent, we have it 1.0. So vapor pressure of the solvent we have. So can we have the number of moles of our solute together with the number of moles of our solvent? So number of moles of our solute, obviously it's equal to mass of the solute divided by the molecular mass of the solute. So mass of the solute, we know that 23.3 grams of a non-volatile solute. So the mass is 23.3. This is divided by the molecular mass, which is 270. So when you divide 23.3 divided by 270, we get 0.086. So this is the number of moles of the solute. So we have our Nx. Let us write here Nx. So Ny will also be equal to the mass. Let us write it here. Ny is equal to the mass of our solvent, which is 10 grams of Y, divided by the molecular mass of Y, which is 62. So 10 divided by 62, we shall have 0.016. So now we have the number of moles. This is a number of moles. And once you have number of moles, you can get our mole fraction, which is X. So we shall have, we are going to substitute in this equation. Maybe we can rewrite it as P solve, vapor pressure of the solvent, minus vapor pressure of the solution, divided by vapor pressure of the solvent, being equal to Nx, number of moles of the solute, which is 0. Okay, let us first keep it as Nx, divided by the total number of moles, Nx plus Ny. So we are going to substitute in that equation and try to solve for the vapor pressure of our solution. So we know that vapor pressure of the solvent, we are going to first maintain it as P solve to save space. P solve minus P solution, divided by our P solve, which is 1.0 0 times 10 to the power 4. This is equal to 0.086, the number of moles of our solute, divided by 0.06 plus 0.16. So 0.16 plus 0.086, that's our denominator. Then 0.0686 divided by answer, and then times 10 to the power 4. So we know that P solve minus P solution is equal to, on simplifying, 3495.9. So we are going to make P solve the subject by taking this other side and then bring this one this other side. So we shall have our 1.0 times 10 to the power 4, which is our piece of the solvent, minus 3495.9 is equal to this solution. So this will be equal to, so 10 to the power 4 minus answer. So we shall get 6.504 times 10 to the power 3 newtons per meter squared. So this will be the vapor pressure of the solution. As you can see, it's lower than that of the solvent because it's to power 3. So try and follow through this video and see how we have arrived to this answer. Thanks for watching.